Hi everyone, in this video we'll solve or find some derivatives of inverse trigonometric functions, and we have 6 of these inverse trigonometric functions. These are sine inverse, cosine inverse, tan inverse, cotan inverse, secant inverse, and cosecant inverse, and these are the rules of derivatives of these inverse trigonometric functions. So in part A we have f of x equals sine inverse of x squared plus 4x, and you have to find the derivative of this function. So you have to put the inside function u and use the derivative of sine inverse of u. So you have to find the derivative of the inside function divided by square root of 1 minus the inside function squared. So f prime of x equals the derivative of the inside function, which is 2x plus 4, divided by 1 minus square root of 1 minus the inside function squared. And the inside function is x squared plus 4x all squared. Now in part B, you have to find the derivative of the function g of x secant inverse 3e to the x plus 3 to the x minus x cubed. So you have to name the inside function u, and we have g prime of x equals the derivative of the inside function as derivative of 3e to the x is 3e to the x, because derivative of e to the x is the same, plus we have 3 to the x exponential function. You have to write the same function, but you have to multiply it by ln 3. Then you have to find the derivative of x cubed, which is 3x squared. Now we talk about secant inverse of x, and this is the derivative of secant inverse. Derivative of the inside function divided by absolute value of the inside function 3e to the x plus 3 to the x minus x cubed multiplied by square root of the inside function squared 3e to the x plus 3 to the x minus x cubed minus 1. And this is the derivative of the second function. Now in part C, we have the function y equals 6 to the power tan inverse of x. And as you know, if we have number raised to a power of function, so you have to find the derivative of the power multiplied by the same function multiplied by ln of the base we have on the question. So the base is 6 in our question, so y prime equals the derivative of the power or exponent, and the exponent is tan inverse of x, and this is the derivative of tan inverse of x. In general, the derivative of the inside function divided by 1 plus the inside function squared, but the inside function is x, so the derivative of x equals to 1 divided by 1 plus the inside function square, which is x square, multiplied by the same function 6 to the power tan inverse of x multiplied by ln 6. For more simplify, y prime equal 6 to the power tan inverse of x multiplied by ln of 6 divided by 1 plus x squared. In part D, we have y equals a square root of cotan inverse of x. And this is the rule of the derivative of cotan inverse of x. But here we have square root, and derivative of square root of a function equals the derivative of the inside function divided by 2 times the same square root you have in the question. So y prime equals the derivative of the inside function, which is cotan inverse of x, is negative 1 divided by 1 plus x squared. This is f prime of x divided by 2 multiplied by square root of the inside function. So 2 multiplied by square root of cotan inverse of x. Now you have to combine the denominators and you will get minus 1 over 2 multiplied by 1 plus x squared multiplied by square root of cotan inverse of x. Now in part E we have ln function, natural logarithm function, and to find the derivative of this function, as you know, if we have len a function, then the derivative will be the derivative of the inside function divided by the inside function, and the inside function is cosecant inverse of x, and this is the derivative of cosecant inverse of x. So h prime of x equals the derivative of the inside function minus 1 divided by absolute value of x multiplied by square root of x squared minus 1. This is the derivative of the inside function divided by the inside function, which is cosecant inverse of x. Now you have to combine the denominators and you will get the derivative of this function. So we have minus 1 divided by absolute value of x multiplied by cosecant inverse of x multiplied by square root of x squared minus 1. And in part F, you have the function of x equals secant inverse of x plus cosecant inverse of x. So what is the derivative of this function? F prime of x, it is a direct application. So secant inverse of x, this is the derivative, 1 over absolute value of x multiplied by square root of x squared minus 1 plus the derivative of cosecant inverse of x, and this is the derivative of cosecant inverse of x, and it's equal to minus 1 over absolute value of x times square root of x squared minus 1. Since we have the same terms, so this one minus this one equal to 0, so f prime of x equal to 0, which means that the function we have in part F is a constant function. And that's it. Thank you.